Welcome back. This will be our last lesson on the topic of surface area and volume. Today we'll be focusing on the volume of a composite solid. Here on the screen, I have provided you with a list of formulas for finding the volume of various types of solids. Here I have compiled common solids that you will be seeing in various different types of questions where they will combine them together to make a composite solid. However, there will be a time where, let's say in an exam or in a topic test, you will have to deal with non-common solids. So for example, a hexagonal prism, where then you will need to use your knowledge about the other area formulas of the special quadrilaterals. So for example, trapezium, parallelograms, rhombus, and kites to solve that. But in this case, in this video, I'm going to focus on the common solids. So volume formula of a rectangular prism is V equals L times B times H. How we got that is from that little recap that I did on the first part of the volume, where we talked about it is the capital A, which means area of a cross section times the height. Area of a cross section is if you've got a tissue box, you cut it every single time. The shape that you get every single cut would be a rectangle, which means that we need to substitute and replace the capital A for the area formula of a rectangle, which we've done there. We've got a cube, again, replacing the capital A with the area formula of S cubed, which means side times side, or S squared. Triangular prism, half times base times height of triangle, times height of the prism. Here I'm going to preface. So height of the prism means this part right here. If it is the height of the triangle, it's the stuff that's the inside of the triangle. Okay. Draw this out if you think that you're going to forget it. Please don't get those two confused. Now, again, cylinders, every time that you're going to cut a cylinder, the shape that you will get every single time will be a circle. Again, so thus we need to use the area formula of a circle times the height. Lucky last is the two formulas that we learned in the last two lessons. One thing I would like to preface is with the volume of a sphere. It is radius cubed, not radius squared. All right, let's get started on our question. So find the volume of these composite solids, or this particular composite solid. All right, so my first step, if we were to look back in year 8 and year 9, we used one strategy where it was, okay, let's identify what type of solids or what type of shapes I can see. In this case, what I'm going to write is, what I can see is, well, I can see a sphere-like solid, but it's cut in half. What I call that is a hemisphere. All right, and I'm just going to put in brackets, hemisphere means half of a sphere. Okay. Now, what else can I see? I can see a cylinder, and that's all. I don't see any other solid or shape other than those two. Now, that's one really good strategy. What I would like you to do is notice how the hemisphere and the cylinder has something to do with circles, right? In our question, it seems like 16 centimeters is a diameter. So first, our next step before solving the volume is converting the diameter into radius, right? The diameter is 16 centimeters. We know that the radius is half the diameter. Thus, we need to do 16 divided by 2, which we will get as 8 centimeters. All right, that is super easy. We've done that. Now, what I need you to do, this is one strategy. I want you to first figure out the volume of the hemisphere first, then the volume of the cylinder, then add those two volumes together. Okay, so first off, volume of the hemisphere, I've written down my my formula. So here I've written the formula of the sphere, but because a hemisphere is half of a sphere, I've times it again by half. Okay, so half times 4/3 following the formula times pi times the radius was 8. Put that into the power of 3, put that all into your calculator, and this is what you should get. Now, because we're dealing with different types of shapes, I don't want to round it just yet. I want to write the whole number, right? The whole decimal or number down. Don't round it up or round it down yet. Okay, this is what I will get. Now, again, second step is find the volume of the cylinder. Written down my formula. Let's just sub in what R is, which is 8 times our height. Let's look at our little diagram. The height of the cylinder is 5. So let's add that in. Put that into your formula and you should get this right here. Again, don't round it just yet, because sometimes you can make little silly mistakes because of this. Now, once we've done that, let's put in total volume equals, we need to add the volume of the hemisphere plus the volume of the cylinder. So I'm going to write down the numbers that we got for the volume of a hemisphere. Multiply, add that to the volume of a cylinder, which is this right here. Put that all into your calculator and you should get 2077.64 centimeter cube. This here is where I suggest you round it, right? And that is it. I will see you next time. Bye.